Yo, what is going on, pre-algebra class? As your teacher, Mr. Lopez, coming at you with another lesson from Chapter 12, Lesson 4 on stem and leaf plots. Stem and leaf plots are a different way to organize data, but it's pretty easy to understand. So a stem and leaf plot is a graph that displays numerical data, so dealing with numbers only, arranged in order. Each data item is broken into two parts, either a stem or a leaf. So here we have an example of a stem and leaf plot where the number on the left is the stem and the number on the right is the leaf. Now the stem is the digit or digits on the left of the number and the leaf is a digit on the right. So this would just mean tem, all right, because this is a 1 and 0. In this case right here, we would have a total digit of 5.52 where 5 and the decimal are the stem and 5.2 are the leaf. Or we can go ahead and write this as 5.5 as a stem and 2 as a leaf. All right, but these would be the same values. But if I had like a large group of numbers, it can mean something different. So here's what it's going to boil down to. All right, the stem is going to be the place value that it has in common with other digits, and the leaf is going to be the number that changes. Okay, so let's go ahead and look at example number 1. Make a stem and leaf plot for the data below. So they have prices of digital music players in dollars. So one of them costs $189, the next one $214, $200, $195, and so on. All right, this is how much everything costs. If I look at this, I can see that the cheapest music player would be $189, and the most expensive would be, looking at this, $214. All right, I mean, I just kind of look for the biggest and smallest numbers. So that means it's going to range between $189 and $214. So, because all of these have, they're all 3-digit numbers, where they have the last digit might be alternating, might be changing, we're going to go ahead and make a stem and leaf plot like this, where if I take this data, all right, all the numbers that start with 1, 8 go right here. And this would mean 189. Okay, how do I know that? Because each stem and leaf plot will have a key, and the key tells you what it means. Like in this case, 1, 9 as a stem and 2 as the leaf means that this is $192. All right, 192. Now, some of these numbers might have the same stem, like 190 and 192. They have the same stem. They both start with 1, 9. So 1, 9 goes here, and all the numbers that have a different last digit go in the leaf section. So this would mean there's 190, or 192, or 193, or 194 somewhere in here. And in fact, there are actually two numbers that actually have 195, both right here and right here. So they just put 2 different 5s in the leaves. All right. What are the values that have at least $200? Well, $200, 201, 201, 205, 208. All right, 20, and then the digit at the end. Then we have how many prices are there that are at least $210? Well, 211, 214. So all I'm doing is putting these in order, where I put the stems, the digits in front that they have, place values they have in common in the front, and all the different last numbers in the back. Cool? All right, let's go ahead and look at standards check. Let's practice this a little bit more. All right, standards check number 1 says the monthly high temperatures for Death Valley, California are shown on the left. Make a stem and leaf plot for the data. So I'm going to go ahead and start by just drawing a line going down, and this is going to separate my stems from my leaves. All right, now I look at the data, and my first strategy thing I want to figure out is, all right, what's the biggest and smallest number on this list? You notice that they're not in numerical order. And looking at this, I can see that the smallest one is 86, and the biggest number is 134. So that means that for my stems, all right, they have to range between 80-something, 90-something, 100-something, 110-something, 120, and 130. All right, so the numbers range somewhere between there. Now, what I'm going to do is I'm just going to go ahead and cross off the numbers that I used to make sure I represent all my numbers. And at the end of it, I'm going to count out how many numbers just to make sure I have all the data in there. So my smallest number was 86. So I'm going to put an 86. All right. The next value that had an 80 something was 87. So I'm going to put a 7 next to it. This represents the data values for 86 and 87. Okay. How do I know that? Well, I'm going to go ahead and make my key. Actually, let's do this in a different color. Let's just do this in red. All right. So my key tells whatever reader or whoever sees this plot what everything means. So I would say, for example, 86 or 8 line 6 means 86 degrees Fahrenheit. All right. It doesn't really matter which one you use. I usually just do the first data point so that they say, okay, what is 86? Okay, here's what it means. Now I can go ahead and continue making my leaves. All right. Do I have any values for 90? Well, 91 and 97. So I'm going to put these in order from smallest to biggest. 91 and then 97. Done with those. Do I have any values in the 100s place? Well, 101, or anything that starts with 1 and 0. That's the only one. So 101. All right, used it. Do I have any values that start with 1, 1? Well, 111, 113. So 111, 113. Boom, boom. Do I have any values that start with 1 and 2? So 120, 125, 126, and 120 again. So there are 2 120s. There is 125, and then there's 126. So I use those, and I cross those out. All right, we have one value that goes into the 130s, so that would be 134. And this would be my stem and leaf plot. All right, where I have everything that I need with all the information listed. All right, so how many data points did I have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 leaves, so there should be 12 digits here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I'm just doing this as a double check to make sure I have all of them in there, all of them accounted for, everything is in order, and now I have my stem and leaf plot. Cool, cool. Now, a back-to-back stem and leaf plot shows two sets of data in the same graph. And the reason they do this is because it might make it a little bit easier to compare the data when you see them. Like in this example right here, we have two sets of information, winning times for the 100-meter dash in seconds. So in 1960, the winning time for men was 10.2 seconds, and for women was 11.0. And they just went year by year, all right, skipping every 4 years, and they got all this data. Now you can put two sets of data in the same stem and leaf plot, putting the stems in the middle and putting the leaves on either the left or the right. Now notice this is labeled men's times, all right, and women's times, so we know what each thing means. Okay, so it looks like, according to this, the men's times were where they said this would mean the stem is going to be the middle number. This is 10.0, and I know this because it says it means 10.0, and this would be 10.5. They just kind of give an example of what both of them mean and how they're shared together. So this time would be 9.9, 9.9, 9.9, 9.9, 9.8, or 10.0, 10.0, 10.0. So they put the smallest number closest to the stem. All right, and they did the same thing for the women's times. Okay. Now, use the median and mode of each data set to compare the data. All right, remember the median is just an average, and the mode is the most common value. All right, the most common. All right, so the back-to-back stem and leaf plot gives it the impression that women's times are greater than the men's winning time, meaning that it takes more time for women to finish the race than it takes for men to finish the same race. And I can look at this and I can kind of see that because there's more men's times in the 9 seconds. There's actually no women's times in the 9 point something seconds. All right. And there are actually no men's times in the 11 point something seconds. So this would tell us that typically men have a faster time than women do. So the last example that we're going to go ahead and do is standard check number 2, where they want us to draw a back-to-back 7-leaf plot for this data that talks about the annual sales of videos and CDs. All right, so over a 10-year span. So the first thing I'm going to do is I'm going to try to figure out what's the biggest and smallest data point that I have to represent. It looks like my smallest data point was 15, and my biggest data point was 30. I just kind of look through this and I try to see are there any numbers. There's 15 a couple of times, but there's only one number in the 30s. So that means my stem is going to start with a 1 in the middle, a 2, and then a 3. What I can do is I can give myself a little bit of room on the bottom here so that I have some space for the key, because all these data points are going to fall within the 10, 20, or 30 range. Now I have to decide what my key is going to be. Or I could just make an example of this stuff. I can say, for example, let's do refresh. Let's say here is my key. All right, where I can say if this number in the middle is, I'm just going to make up a number 20 and then 5, then this means 20 million sales. And this would mean 25 million sales. Okay, kind of smushed, but that's what it means. 20 and 25. Now, I already went ahead and say video sales are going to be on the left, CDs are going to be on the right. It's up to you and how you want to do it. I'm just going to go ahead and start looking for any values for videos that have start with the 1 as my lead place value. So I have 15, 16, and 17. So that means I'm going to have 15, 16, and 17. I put the smallest number close to the stem, and I already used these guys. All right. Now I look for CD sales that have start with a 1, 16, 17, 16, 18, 15, 16, 18. So this one has a lot more 1-digit place values. So I'm just going to go ahead and put these in here. The smallest term was 15, and then there was 16 used once, 16 used twice, 16 used a third time, a 17 in there, and then 2 18s. 18, 18. Cool? Cool. Now I'm going to go ahead and fill out the rest of this like magic. It's just going to pop up. And just like that, we have our 7-leaf plot filled out. I went ahead and found out all the numbers that start with a 20 something and the 20 place value and put them over here. And same thing for CDs. And there's only one digit that even had a 30 place value. It is over here in the video sales. That's my 7-leaf plot. So it says draw the back-to-back 7-leaf plot, which we did. And then use the median mode of each data to compare it. So if I wanted to compare this is actually really important, because why would we do this unless we had some sort of reason to do it? And what this does is this gives us a visual picture as to like which one had more sales. All right. So looking at this, you would look at this and you'd probably say that video sales have more sales in the millions, because for one, it's the only place value that has a 30. All right. But also most of its place values are in the 20s. Whereas most of the CD sales are in the tens of millions. Okay, if you look at the mode is probably going to be either 22 or 24 on this side because it's the highest occurring number. And this side it's 16. 16 is the highest occurring number. All right, so that's how you would compare it. Using words, you can say there were more video sales than overall CD sales for the same 10-year period. And I mean, that's it. You're going to be writing your stems, and the leaves go on the sides. The smallest number goes on the inside, or closest to the stem. And we always want to have a key so we know what this means. All right, that's it. Have fun doing your homework.